Hello everyone, I'd like to welcome you to this video titled Graphing on the Coordinate Plane. And the goal for this video is for you to understand how you locate and name points in the coordinate plane. Now for this video, you will need to get out your math book and turn to page 331 and get out a pencil. So let's take a look at page 331. It says naming points on the coordinate plane. So there's a few things that is important to understand right from the beginning. So it says a coordinate plane is formed by two number lines that intersect at right angles. So you can see right here, it's at right angles that are being created. The point of the intersection is 0 on each number line. So you can see that's also called the origin right there. So where they intersect is 0 on the number line. So a couple things, more than just a couple things, a lot of terms that we'll be talking about as we move through this chapter, chapter 12. So first of all, the two number lines are called the axes. Okay, so it is important to understand two number lines called the axes here. All right, now the horizontal axis is called the x-axis. So when we're moving on a coordinate plane, this is called the x-axis. The vertical is called the y-axis. So that's important to understand. So this is the y, you can see it's labeled right up there. And you can see x-axis is the horizontal one. The point where the axes intersect is called the origin. We already talked about that. And origin, the number for the origin right there is 0. Something that you may not know about a coordinate plane, the two axes divide the coordinate plane into 4 quadrants. So you can see quadrant 1 is there on the upper right hand corner, and then it goes counterclockwise, quadrant 2, quadrant 3, quadrant 4. And you can also see that these are labeled with Roman numeral numbers. Okay, so 1, 2, 3, and then the IV represents quadrant 4. So 4 total quadrants. So moving along with these terms, an ordered pair, I know you've learned about ordered pairs in previous grades, but an ordered pair is a pair of numbers that gives the location of a point on a coordinate plane. The first number tells how far to the right or left the point is located from the origin. So you always start on the x-axis, either move to the right or the left on the x-axis. Then the second number tells how far up or positive or down negative the point is located from the origin. So you always start on the x-axis and then move either up or down based upon a positive or a negative number. The numbers in the ordered pair are called coordinates. Okay, so it is important for you to understand that. And also the first number is the x coordinate, the second number is the y coordinate. So for example, if I have -2, that would be my x coordinate. +3, that would be my y coordinate. Okay, so a lot of terms to think about whenever we're graphing on a coordinate plane. You'll want to reference these terms throughout this chapter on page 331. So you may even want to put an earmark in your book to have this page ready to go and accessible throughout this chapter. Now let's take a look at a couple skills here. What we're going to do is we're going to identify the coordinates of each point, and also we're going to name the quadrant where each point is located. So when we're looking at a coordinate plane, it's important to understand the intervals as we're looking through this. Now, just because it goes from 0 to 2 and then 4 does not mean that they're intervals of 2. You got to figure out how much each section represents, okay? And we can see with this, it has a 0 at the origin, and then there's the 1, and then there's the 2, then there's a 3, there's the 4, there's the 5, and then there's the 6. So just intervals of 1, all right? And you can see that on the x-axis and also the y-axis, intervals of 1. So that is very important to understand. Okay, so what we need to do, we need to identify the coordinates of each point and then name the quadrant. So with this, it's important to understand that when you see a point, you need to figure out what um, x-axis or x-coordinate it's aligned with. Okay, so we can see that G is aligned with +4. All right, and then also whenever we're writing the coordinates, we have to have parentheses there. So it's +4 it's lined up with. And then we need to see which y-axis, which y-coordinate G is lined up with. So you can see it's lined up with -4. So +4, -4 there. Or you can just say 4, -4. So that is G. Now thinking about which quadrant it's on. So understand that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You can see that G obviously is located in quadrant 4. And remember, we're not just writing the number 4, we got to write that in Roman numerals just like that. All right, so we could say that any number that has a positive x-coordinate and a negative y-coordinate is going to be in quadrant 4. Take a look at letter E. Again, first x-coordinate, that first number of that ordered pair, needs to be aligned with the number on the x-axis. So we can see E is right in line with -2. So that is -2. And then for the y-coordinate, what number is aligned with? That's +4. So we have point -2, 4. What quadrant is it in? You can see easily here, E is in quadrant 2. All right, let's take a look at F. Again, we need to figure out, first of all, when we're writing an ordered pair, which number on the x-coordinate is that point lined up with, and that's going to be our first number of the ordered pair, and that is a 3, so +3. And the next one is the y-coordinate, and that is 2. So we have point 3, 2. What quadrant is that in? That's in quadrant 1. Now what I would like for you to do is work on number H all by yourself. You can pause the video, work through this problem, and when you press play, I will have the answer for you. So I would like for you to pause the video now. Okay, so H, what we can see here, with the x-coordinate, it's aligned with -1. Y-coordinate, it's aligned with -3. And we can see it's in quadrant 3 right there. So that's how you take a look at a point and name its location. Now what we're going to do is we are going to see a point on the coordinate grid, and we're going to label points and graph and label points on the coordinate grid together. So let's take a look at page 333. We'll work through this problem together. So for number 6, we have letter P. It's -4, 2. Okay, so point -4, 2. So the first thing that we do is we always start on the x-axis. Okay, and the way I remember that is x comes before y. So that means I'm either moving right or left on my x-axis first. So we can see I find -4. So I have this point right here. I do not graph anything yet. I only graph whenever I find the location that's aligned with both the x-coordinate and the y-coordinate. Then I graph my point. So we can see it's -4 on the x-axis, and then +2, it goes up, +2, and then we just graph our point right there, and that is letter P. And I know a lot of you have done this already, and you're probably pros at this, so we won't spend too much time there. So next one, we can see letter Q, 3. So we're going to go 3 on my x-axis. All right, +3. And then it's 2.5. Okay, so we go 2 there, and then we understand, I didn't say this at the beginning, but this is all 1 intervals here. Okay, so just intervals of 1. So 2.5, that's going to be in between the 2 and the 3 on the y-axis, and that is letter Q. Let's take a look at number 8. So letter R is point -4.5, -5. So again, we move on the x-axis, either left or right. Since it's a negative number, we go to the left, and that's -4.5. So we are -4.5, which is right here. And then we go down -5, and we put our pointer on our graph just like that, and we label that letter R. Let's take a look at letter S, number 9. 0.4, -5. So again, we go 4 on the x-axis. We don't plot our point just yet. It could be very tempting to do that. We don't do it yet. And then we go down -5. How do I know it's -5? I can look right here in my y-axis. All right, so +4, -5, and I graph my point right there, and that's letter S. Finally, letter T, we go -2.5, 0. So we go -2.5 on the x-axis, and we don't go up or down at all on the y, so we just plot our point just right here on my graph, and we label that letter T. So that is how you graph and label points based upon the ordered pair that you're given. So let's take a look at the bottom part of page 333, and this will be the final part of our video here. It says reading scales on axis. So that says the scale of an axis is the number of units that each grid line represents. So far, the graphs in this lesson have had a scale of 1 unit. That's not too difficult, but oftentimes graphs will use other units, especially if they're dealing with larger amounts. So for example, example 3, this is a real world type problem. It says the graph shows the location of a city. It also shows the location of Gary's and Jen's houses. The scale on each axis represents miles. Now you can see the scale here. We go from 0, and then there's a 10, and then there's a 20. So there's not necessarily 10 lines in between the 0 and the 10. However, you do see lines in between that. Okay, so you can think about, all right, there's the origin, which is 0. There's another line there, which is halfway, and then there's a 10. So think about what number is halfway between 0 and 10, and that would be 5. So you can see that the scale for this are units of 5. Okay, so 0, 5, 10, 15, 20, 25, 30. And the reason why they do that is a lot of times with some of these larger numbers, you're not going to have enough lines on your coordinate plane, so you have to have larger intervals there between each line. So it says use the scale to describe Gary's location relative to the city. So it says each grid square is 5 miles on a side. So each of these squares represents 5 miles. All right, now we know that the city is at the origin, which is 0. Okay, so it says Gary's house is at -25.15, which is 25 miles west. You can see how this works, 25 miles west, which would be to the left, and then 15 miles north. So that's how you kind of represent a real world problem here. So this axis, so the north would be going up here, east would be to the right, south, and then west. Okay, so we have point -25.15, so you can see Gary's house is right there. It says describe the location of Jen's house relative to Gary's house. So you can see Jen's house is 5 miles east and then 15 miles north of the city. Okay, how do we know that? 5 miles east to the right, and then 15 miles north there up on the y-axis. All right, so if we're taking a look at Jen's house relative to Gary's house, you can see Jen's house is located 6 square grids to the right of Gary's house. How do we know that? We have 1, 2, 3, 4, 5, 6 square grids. All right. Now, because of that, because we know that each square represents 5 miles, what you can do is you can take 6 square grids, multiply it by 5, and that'll give you 30 miles away from Gary's house. Now, if we want to get really technical, we could say that Jen's house is 30 miles east of Gary's house. All right. So that's how you could represent that looking at this coordinate plane. Now let's take a look at that question on the bottom there, number 11. It says Ted lives 20 miles south and 20 miles west of the city represented on the graph in example 3. So if we would say 20 miles south, 20 miles south and 20 miles west of the city. All right, and his brother Ned lives 50 miles north of Ted's house. Give the coordinates of each brother's house. So Ted, when we think about 20 miles south, 20 miles west, so we could see this would be right here on the coordinate plane there. They said south and west, they kind of mixed it up for us, but understanding that this would represent west, this would represent south here. Okay, so that would be, Ted would be the coordinate point -20, -20 there. We want to write that down there at the bottom. All right, now we know that his brother Ned lives 50 miles north of Ted's house. So understanding where Ted's house is, we'll put T for Ted. We know that it's going to be 50 miles north, and understanding that each section represents 5 miles. Okay, we could just simply do an easy division problem. 50 divided by 5 is going to give us 10. That means it's going to be 10 squares above Ted's house on the coordinate plane. Okay, so it's just north, so we're not moving right or left on the x-axis. We're just moving 10 sections up to the top there. All right, and that's going to go all the way up to, make sure I'm in line here, all the way up there. You can see which would be Ned's house. And what would that coordinate plane be? We know it's right in line with Ted on the x-axis, so that would be -20. And then on the y-axis, it's right in line with 30. So that's how you take a real-world situation and graph it on a coordinate plane. Again, it is very important to understand the intervals, okay, that each graph has. That is very important, or each coordinate plane has. It's very important to understand that so you can put your points correctly on the coordinate plane. So this concludes the video on graphing on the coordinate plane. If you have any questions about this concept, please come and see me.